Okay folks, in this lesson we take a look at the more important utility nodes. So let's go to the create a shader network and let me just assign it to the sphere for now. Now down here in the utility nodes, the first kind of important node is this cache node, and it can be used to avoid re-evaluating costly parts of the shading networks. For example, if you have a huge volumetric sim going on, to avoid re-evaluating it all the time, you can actually cache it and connect the output of the cache node to the input of the next node in the chain. Okay, now the next important node here is the camera projection, which allows you to perform camera projections of an image over an object. So let me just press Ctrl Tab and load an image. Let's load this floral pattern here. Now let's say I want to project this image through my camera over the sphere object. So I can simply connect the output of my image to the projection color of the camera projection node. Then you need to actually define the camera. In this case, let's use this camera. And let me also assign this shader to the glass and also to the object here. Okay. And if I just run the IPR and move around, you can see we have basically projected this image through our camera over our objects. Let me just undo the view a few times. Let's see, let me just delete this, or we can just delete this. Then we have this kind of clamp node, which basically clamps the input between 0 and 1. So if I just connect this image that we currently have to the input and connect the clamp to the Arnold Beauty, I can simply, it's like a range node, so I can, let's say, instead of 0 and 1, go to 0.3 and 0.8, or I can use something like 0.9 and 0.1 for my min and max and basically invert the image, right? So okay, so let me just delete these two again. Next we have this complex IR shader, which was designed to work with the standard shader prior to Arnold 5, and now we have most of what the complex IR does within the standard surface shader. So let's skip this. Then we have this facing ratio. Facing ratio gives you a number between 0 and 1 that tells you if the point being sampled is facing towards or away from the camera view. A value of 1 means that it is facing the camera heads on, and a value of 0 means that it is facing 90 degrees from the camera. So that is basically Fresnel effect. Based on the incidence angle, you get outputs from 0 to 1. We can obviously, as you can see right now, the frontal faces are getting 1 and the edges are getting 0. We can obviously invert the effect. Now the frontal face is getting 0 and the edges getting 1. We also have two other options here, bias and gain. Gain controls the gradation between 0 and 1, and as I decrease this value, as you can see, the gradation becomes less and less, and if I go to a very small value, you can see now we only get 0 and 1 and there is no gradation and no grayscale values. Then we have bias, which allows you to offset the effect towards the frontal or the edges. So you can see, you can simply move this. Now you can use the data that the facing ratio gives you whenever you want. For example, if you want to control the Fresnel reflectivity of your standard surface shader manually, you can, for example, connect this facing ratio node to the specular weight of your standard surface shader. So that's up to you. Then we have this pass-through node. SolidAngle explains it like this: evaluates any shading network connected to the evaluation 1 to 20 inputs. The pass-through input is evaluated first and is passed as is to the output. This shader is useful to force the evaluation of parallel shading networks that are not part of the beauty pass, whose resulting value you need to store in an AOV. Pass-through is very useful when you're trying to write AOVs. If you remember, we discussed ambient occlusion and we said we can export it as a separate path using AOVs. We can do that using the write AOV node in conjunction with the pass-through node. I don't want to confuse you with AOVs at this time, but I talk about how to use write AOV nodes in the rendering section of this course, and there I use pass-through node also. You can check it out in the rendering section of the course, but I suggest you wait. Then we have this space transform, which converts the input coordinates from one space to another. We have switch RGBA and switch shaders. And these allow you to define up to 20 inputs and choose between those inputs using the index value up here. So as you can see, we have switch RGBA for color and RGBA inputs, and we have switch shader for shader and surface inputs, right? So let me just delete these two. And now if I want to use this switch shader practically, let me first of all drag into Lambert shader. Let's say one is this orange, another one can be this pink color. Now I can connect the first Lambert shader to the input 0, the second one to input 1, and connect the switch shader to the Arnold Beauty. And now as you can see, we only see the orange Lambert shader because the index is set to 0. So now we are getting our input 0. If I want to get my input 1, which is this pink Lambert shader, I can simply change the index to 1. Okay? And the switch RGBA is the same thing. For example, if I, let's see, load two images here, let's say this one, control drag, and this one, and I can connect them to the input 0 and input 1, and let's use this switch RGBA to control, for example, the color input of our second Lambert shader. Okay, now I can go between index 0 and 1 to get my first or my second texture. Okay, so that's switch RGBA and switch shader. Next we have this UV transform, and if I drag it here to the work area, UV transform enables you to modify UVs locally, thereby controlling how a 2D texture is placed onto a surface. You can control the position, size, and rotation of an image on the surface using the scale, translate frame, and rotate frame attributes. You can also control how the texture is styled within the frame using the repeat, rotate, offset, mirror, stagger, and wrap attributes. So basically UV transform is a simple set of UV tools that allows you to adjust the UV of your textures right within the shader network. So for example, if I just take a look at this sphere here, and let me just simplify. So I'm just control drag this. So that's what we have currently. Let's drag another Lambert. Let me just delete this other ones. And now let's connect our Lambert to the Arnold Beauty. Connect the image that we have to the pass-through input of the UV transform node, and connect the output of the UV transform node to the color attribute of the Lambert. Now I can use the UV transform to actually adjust the texture. So I can, for example, scale the frame. Okay, just render this. So I can maybe use something like 3 here. Now bigger frame again. Let's get back to 1. I can rotate. Okay, I can use the transform section to have, for example, more repetition if I wanted to, or offset or mirror or flip. So you got all of these different UV options that you can utilize here. And we talked about the triplanar, and we have this trace set. So let me quickly discuss that. This node can be used to exclude objects from each other. Let's say I don't want to see, for example, let me just simplify this. Let's say I don't want to see the effect of the sphere in the floor or this backdrop object that we have. I don't want to see the shadows from the sphere on the floor. I don't want to see any GI contribution from the sphere on the floor. I don't want to see its reflection on the floor, and so on. So for this, let's actually open up the standard shader that's called backdrop here. And this is applied to the backdrop object, this grid object that you can see. So let's drag a trace set here. Now first you need to define a trace set. Let's call this trace set something like sphere. Now connect the output of the standard surface shader to the pass-through input of the trace set, and connect the trace set output to the Arnold Beauty. Now nothing changed in the IPR, so let's select the sphere object here and add an Arnold parameters tag. Now down here you have trace sets. Let's have at least one trace set, and as you can see we have a new field called Vol.U1, and if you watch the IPR you see we can no longer see the shadows of our sphere on the floor. To have a bit more control in case we had more than one trace set, let's type sphere in Vol.U1 or whatever name you have used in the trace set field of the trace set node. As soon as we do that, we are back to where we were because the inclusive checkbox is enabled in the trace set node. When a trace set is inclusive, rays are traced against tagged nodes, but also against nodes that are not tagged at all. So we need to uncheck inclusive. So now as you can see, the backdrop won't recognize the existence of the sphere at all. As you can see, we don't see the shadows of the sphere, and if the backdrop was reflective, we couldn't see the reflections of the sphere on our backdrop as well. So those are the more important utility nodes. There are some other nodes that you can check them out on your own, but that's about the utility nodes. Also, in the surface nodes, we discussed most of these nodes, so I don't think there is anything specific we need to talk about. We still have these texture nodes that we need to take a look at them in our next lesson, even though we have discussed most of them, but we will be taking a look at some of the more important ones in the next lesson. So see you there.